Okay, so if in a log we input the results and we get out the exponent, okay? So that's complete inverse of an exponential. So flipping the x and the y. So if I take this basic equation, log base x, I could add an a in the front, I could put a b there, a c there, and a d there if I wanted to transform stuff. Okay. Find this page. Okay, so I'm going to graph y equals 3 to the x, which is an exponential function. So when I start this, I always do the same thing. That's what I do every time. 3 to the negative 1, 3 to the 0, and 3 to the 1. I pick 3 exponents to put in. Okay, what is the result when you do 3 to the negative 1? 1 over 3. Anything to the 0 is 1. And anything to a 1 is itself. So if this is an exponential, the coordinate would be negative 1 comma 1/3. This coordinate would be 0 comma 1. And this coordinate would be 1 comma 3. Okay, then you learned that the shape of it is asymptotic. So it would go like that and flatten. Because the next one would be 1/9, 1/27, 1 over 81. It's just getting smaller and smaller and smaller, closer and closer to 0. So you need an asymptote, which would be y equals 0. Okay, so we did this. An anchor point, 0, 1 is always on that, obviously unless you've transformed something. The asymptote is always y equals 0, unless there's a shift down or up, something like that. We'll change that, right? And another point is 1 comma 3. Okay, if we know that logs are the inverse, so this is me using a base of 3 again, but now I'm switching the x's and y's. So the anchor point on the log graph will be 1 comma 0. So this point will now move there. The asymptote was y equals 0, so now how will that change? X equals 0. And the coordinate 1 comma 3 will now be the coordinate 3 comma 1. Okay, can we also change this coordinate? This one would be 1/3 comma negative 1. So those are my 3 points on the log curve. So 1/3 comma negative 1. Okay, and now do you see the shape? Okay, so I took the original exponential points and I just changed them all. That's what I'm doing. Let's talk about the domain and range of each. So this one has a domain. It will go negative infinity to positive infinity. And the range, the lowest is 0 with a round bracket, because it's an asymptote of 0 to infinity. And then what do you think about this one? The domain is 0 to infinity, from 0 and then right. And then the range is negative infinity to infinity. So what's the connection with the domains and ranges? They would switch, right? The domain of this is the range of this. The range of this is the domain of this. Because of the x, y, they're just switching. Okay. So what is the basic function here? What's the base that I'm dealing with on this question? 5. Okay, so 5 is my base. So I'm going to start every question the same. 5 to the negative 1, 5 to the 0, 5 to the 1. I just pick 3 exponents, and those are the easiest exponents to pick. So I get 1/5, 1, and 5. Okay, this is a log graph, so I write the coordinate backwards, like that. Okay? So if an exponential, you write exponent, comma, result, but a log, you write result, comma, exponent, right? Because we're thinking backwards now. Okay, so I'm going to graph this function. Okay, so those points. Okay, are we good with that? The log function. So that's the basic shape of a log function. Now, let's talk about the transformations. What letter would this negative symbol be? Negative 1 is the what? A, B, C, or D? An A. And when I had the subtract 2 there, a C. So I'm going to go like this. How do I do my x plus 2 negative 1y. Okay? Remember doing that in the transformation unit? Same thing. X divided by b minus c and ay plus d. Okay, so I'm going to take these 3 coordinates. So if I add 2, this would be 2 1/5, comma, positive 1. Okay, 1, 0 will now go to 3, comma, 0. 5 will move to 7, comma, negative 1. Okay, so there's the 3 points. Okay, physically, do you understand that I'm moving right 2? This is right 2. So what is the new asymptote? That will also move right 2. So if you were ever asked something like, what's the equation of the new asymptote? X equals 2. There it is. So it reflected, the A made a reflection over the x-axis, and we also shifted it right too. So I better be able to physically see those things happening. Okay. Couple things with this. First thing is, there's no base number. There's no little tiny number here at the bottom. What do we now know from yesterday? There's really a secret 10 there. Okay. Now, the looks of this equation are wrong. What's wrong with the looks of it? The B is not how it's supposed to look. So I'm going to rewrite it. So now it will read x minus 4. Okay, so there's the things that we need to know. The secret base is really a 10 when it's not there, and making sure still that our b's are factored out. Okay, so base of 10. So give me the same setup here. 10 to the negative 1, 10 to the 0, 10 to the 1. Okay, so this is a log graph. So the coordinate would be 1/10 and then negative 1. Okay, so exponential or log, you always start, boom, same way, you start. It's just a matter of the order of your coordinate, okay? Okay, so we are going to do x divided by negative 1 plus 4 and nothing to the y, right? There's no a or d. Okay, so what are your coordinates going to become? Okay, what is, without your calculator, negative 1/10 plus 4? So think of 4 minus 1/10 is 3 9/10. Negative 1 plus 4. 3. Negative 10 plus 4, so negative 6. So there's your 3 coordinates. The asymptote will have shifted to the right 4. So there should be an asymptote there. And there's the final graph. Okay, did you have the visual of what the original looked like? Okay, this is kind of the idea of the original. And now we have, do you see it? The reflection and then the right. Okay, last graph. Okay, this is something new. It says ln instead of log. Okay, ln. That stands for the natural log. If I say it in French, maybe it's like log de naturel. That's why it's ln. So the ln, natural log, is the exact same thing as writing log e. Did you do an e example with Mr. Friesen on Thursday? We never talked about the number e. Okay, the number e is a math number. Okay, just like pi. Pi is a math number. Do you know that number? 3.14, da 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 da. Okay, e is a number that we use in math as well. So what is that number? So you have a button on your calculator. Mine is down here at the bottom. If I go e, and I have to go e to the 1. It's like 2.7-ish. Okay? So you have an e button, and the number e, value of it is around 2.7. So it's just kind of like in math. When I say, well, what is pi? You kind of know the number value. Same with e. Okay, so we do the same thing. So we now know this, e to the 1, I'm just going to go 2.7 because on a graph, I can't tell if you're rounding 2.7 versus 2.718. I can't tell that. So e is about 2.7. E to the 0, we just know that is 1. Who is that guy? He's looking, his facial hair is looking darker today. Okay, and e to the negative 1, you can straight just type that if you want, or you can do 1 divided by e. And I'm going to round it because it's on a graph, can't tell. So 0.4 is what I'm going to round it to. Okay, because this is a log graph, my coordinates are going to be written in this order. Results, comma, exponent. Right? Log graphs are just flipping that order around. And we have an A and a C. So I'm going to do x plus 2 comma negative y. Okay, so the coordinates will change. So this would be 2.4 comma positive 1. And then the next coordinate would be 3 comma 0. And then 4.7 comma negative 1. So there's your final graph. Okay, I want to just quickly give you a snapshot recap of what you now know about graphs. Exponential graphs can look like two things. You could either have an exponential graph that grows, or you can have an exponential graph that decreases. Okay, so that's what you learned on last week, Thursday. How do I know when it grows exponentially? If your base is bigger than 1, something will grow. So if my base is 2, it's telling me my population is doubling today. Doubling. It's growing. And this would be if my base is less than 1, so a half. Today I have half the population than yesterday, and then half the population the next day. Your population is decreasing. And then your basic log curve. So that's your basic log curve. So those are your 3 big ideas with graphing, okay? Also know the asymptotes. Obviously here, asymptote is y equals 0. Here is x equals 0. Obviously know the basics of your domain and your range. Okay? Big snapshot idea, that's what you know.